You first.
Awkward start, okay. So we're going to apply what we've been learning with balancing equations and writing formulas to not only write and balance the equations, but we're going to predict what's going to happen.
So to predict what's going to happen, it is going to be helpful for us to be able to classify different reactions into different groups.
Yeah, not every reaction does the same thing, so there's different types will do different things. There's 4 basic types we're going to learn about. These aren't definitions just yet, but these are just ways to identify which type you need to use.
So the first one is synthesis. It involves 2 different elements.
Just elements, keyword, by themselves. You've got one element, and it's not connected to anything. It could be bonded to itself, diatomic elements, but it's not a molecule. Or it's not a compound, I should say. It could be a molecule. 2 different elements, you can have a synthesis reaction.
Decomposition, so we're just looking at reactants that only involve one compound.
One compound, nothing else, just one thing on the reactant side. These are all on the reactant side, by the way. No products yet, because we need to predict what the products are going to be.
The single replacement reaction, which just is one element and one compound.
Okay. And then we have a double replacement where we have 2 separate compounds. Now, based on what you start with, based on these categories, one of those 4 reactions is going to take place. So let's take a look at the definitions and what these things actually mean. First, we're going to go to synthesis.
So you can see in the synthesis we're starting out with 2 elements, and in our picture here you see both of these elements happen to be diatomic.
They do. They can be by themselves or they can be diatomic. You've got an A plus a B, just a generic 2 things by themselves. And synthesis, it kind of sounds like
Synthesizing.
You're synthesizing, you're making something.
Oh, I thought it was like making techno music, like synthesizers.
Oh, you just dated yourself. Happy birthday today, by the way. 30 plus.
Thanks.
The elements, they're separate and they're going to combine together. So you have 2 things, A and B separate, and then they're going to combine. In the pictures, you can see those there. You've got the green ones.
We'll call those A.
Are separate from the brown ones.
We'll call those B.
And they combine together.
Oh, and they make AB
together. AB, or AB2. So, and there it is down. There's an example. You've got potassium and chlorine. Notice one of them is diatomic. That's
one of them
okay.
is not.
It's still an element.
Right, just
chlorine.
pure element potassium,
Now,
pure element chlorine.
Here's where this gets difficult. You know they're going to combine. The formula is not KCl2. It is not.
Well, it's potassium and chlorine, right?
It's potassium and chlorine.
So,
but that does not mean KCl2.
If we know it's potassium and chlorine, though, we can tell potassium's a metal, chlorine's a nonmetal. It's going to make an ionic compound.
It's ionic now. So
Nice.
Since we know it's ionic, we have to carefully consider the charges. Potassium is +1, chlorine is -1. So they form a 1-to-1 ratio, KCl.
All right.
This is very difficult because you're going to want to balance, you're going to want to put that 2 in there. You do not need to balance the reaction when you write the formulas. Now, get the formulas correct first and then balance it because it's unbalanced. So I need 2 chlorines, and then that gives me 2 potassiums, and then you balance the equation after you write the formulas. Most important, though, write the formulas first.
All right, there's synthesis.
Synthesis. What was the second one? You remember?
Decomposition.
Decomposition.
10 points for DJHS.
Decomposition. It is exactly what it sounds like. Molecules are breaking apart.
They're decomposing.
Decomposing.
All right.
Breaking apart. Now this is kind of the backwards of synthesis. You've got AB
together,
and they're going to break apart into their elements.
A plus B. All right.
A plus B.
So it looks like we've got a compound breaking up into 2 different elements.
So since
or more, I suppose.
Yeah, however many there are. You've got A and B. On the left of the picture, they're both together. On the right, I'm going to say the greens are going to be in one spot and the browns are in the other. Yep, there it is.
There we go.
One of them is diatomic and one of them is not.
So
you would have to know what the formulas are to do that.
So if the green ones are A, it's like A2, subscript 2. And if the brown ones are B, then it's 2B.
2B. But the point is they break apart into their own kind. So HGO, there's another example, mercury and oxygen. It's going to separate into its 2 parts. What are the 2 parts?
Mercury and oxygen.
And oxygen, if you were paying attention. So you write mercury and oxygen. Mercury, Hg, sounds
right.
good. Oxygen is O.
Oh,
Diatomic,
diatomic. There it
O2.
is.
Watch out, the diatomics are going to come up a lot in this chapter.
Honkelbrifat.
Honkelbrifat. It is O2, not O. It doesn't matter that there's one oxygen on the left. Oxygen is O2. It has to be 2 on the right.
So we have to go back and balance this equation after we get everything written.
So 2 oxygens on the right, 2 on the left, 2 mercuries, 2 mercuries. All right. Decomposition. The next is a single replacement. Now this one's a little more difficult. The next two are very similar to one another.
So what it looks like in a single replacement, you will have a single element replacing one of the elements in a compound.
Yes, you will.
All
So
right.
one element and one compound. If you see that setup, single replacement. And this is the partner switch
Yeah,
reaction.
I like
one
that
of the
term.
partners.
It's
Thank
like
you.
the boyfriend/girlfriend deal.
Yeah, more or less like, B and C are dancing on the dance floor, and A's going to cut in and take B's partner. So A comes in and B comes out. And they switch places.
All right. So you can see in the picture, you've got the brown ones there all by themselves. We'll call those A.
And then you've got the red and green ones that are connected. And the brown ones are going to come in because those are by themselves, but they don't want to be by themselves. So they're going to switch places with the red. They come in, and one of them comes out to be by itself.
So the red, the B, ends up by itself.
A single switch, single replacement reaction. I like how these definitions fit the title, like single replacement. How do you remember that?
They're very logical.
One thing switching places with the other.
It's actually one place in chemistry where the name actually completely fits what we're doing.
It does make sense. So here's our actual example. Aluminum and iron 2 oxide. Iron 3 oxide. The aluminum is going to come in, but how do you know which one comes out?
That's a good question. And my best answer to that is that it looks like we're looking at iron oxide as a ionic compound.
It is ionic,
Yeah.
metal, nonmetal. Good point.
Ionic compounds generally consist of a metal and a nonmetal, so we know aluminum is a metal, so it's probably going to replace the other metal.
So aluminum's a metal, iron is a metal. The metals are going to switch places. Okay, that's reasonable. So we're going to get iron. Iron's going to come out by itself, and then we're going to get aluminum oxide. So can we just write Al and O, ALO?
Well, no, we have to go back and remember our charges and do the crisscross
that's right.
and figure out what the new subscripts
Aluminum
are
is
going to be.
+3, oxygen is -2. When you crisscross those, you get Al2O3.
And this one works out nice because the Al2O3 it's basically the same thing as the Fe2O3, except you switch the Al and the Fe.
You switch them. So this
looks
only
nice.
looks like this because iron and aluminum have the same charge in this reaction.
Yeah.
It's also important to remember the single elements by themselves do not have a charge. They are neutral. So don't write Al +3 on the left. It's
Or
just
Al subscript 3, as some people like to do sometimes.
And when the iron comes out, it no longer has a charge. It's just going to be iron by itself. Of course, we have to balance this. The oxygens are good, but there are 2 aluminums and 2 irons that we need to balance. Single replacement. If you understood that one, the second one is very similar, except now you have a double replacement.
So this is like the 2-partner switch here.
2 partner switching.
Right, both partners switch.
Nobody's left out at the end. You've got one molecule, or 2 separate compounds, I should say, AB and CD. And these generally take place with ions, so one's a metal, one's a nonmetal. The AB and the CD, if the first one in each molecule should be a positive ion, the second one should be negative, so the positives are going to switch places with the
So
negatives.
we end up with AD and CB.
CB, they switch partners. And there in pictures, you've got blue and brown and red and green
We switched it up. Now we've got green and brown
and blue
and
and
blue
red.
and red.
So the 2 switched partners. In our formulas, we've got barium chloride, so Ba and Cl, and sodium sulfate, Na, and then SO4.
All right. So according to what it says up above, the A and the C switch places. So, and in this case, we're going to switch the barium and the sodium with each other.
Just think about just switching the metals. That'll help you out to get the right product. So if I switch the barium and the sodium, it looks like the sodium is going to combine with the chlorine instead of the sulfate. So we have to remember the charges of those.
Say again, we have to be careful with this because we're talking about ionic compounds, and we're gonna have to figure out the charges and do the crisscross and figure out our new formulas.
So it's
for
not
everything.
it's not Na2Cl2. Sodium is +1, chlorine is -1.
Well, barium, same thing.
All
Barium
right,
is
I did that backwards.
barium is
We'll
+2.
just show you
Yeah,
the
there's
NaCl.
NaCl.
It's +1 and -1, so it's just NaCl.
and remember barium is +2.
And sulfate is
Sulfate's
-2. So +2, -2, crisscross them, cancel each other out. You get one of each. So again, write the formulas first, then balance the equation. It looks like I need more chlorines and more sodiums, and that 2 takes care of both of them.
Perfect.
All right.
All right, there it is. That's the 4 types of reactions we're going to study.
Well, you're going to study. I already know them, but you're going to be tested over them.